In this lesson, we're going to talk about circumference and arc length problems from our chapter 10.9 C problems. The first one is number 16. We have a trash can that's stuck in the corner of a wall, and we want to figure out two lengths. The first one is from P to A, and the second is from P to B. Well, we know that the radius of circle C is 24, so if I draw my radius here, this length is going to be 24. I know that a radius is going to be perpendicular to its tangent, and so that length is 24. I'm going to call this length 24. Let's call this point E. So C to E is 24, and what I've just created is a square. I have square B, P, E, and C. So all side lengths are 24. Now it should be pretty easy to figure out what actually we just figured out what P to B is. P to B is equal to 24. And P to A is just going to be the length here of the hypotenuse from C to P minus the radius. So the hypotenuse, you can see it's a 24-24 triangle, so we have a 45-degree angle. And so C to P is going to be 24 root 2. And I know that PA is going to be CP minus CA. And I found that CP is 24 root 2. And I know that CA is the radius. So I'm left with my result, which is AP or PA is equal to 24 root 2 minus 24. In the next problem, problem 17, we're asked to find the distance all the way around these two, we'll call them pulleys. The distance all the way around this one pulley, and all the way around this pulley here. So we're given that AB, the distance between the centers of the circles, is 24, and we're also given that the radius of circle A is 15, so let's mark that up. Radius of circle A is 15, and I know the radius of circle B is going to be 3. Now obviously these are not drawn to scale. So what we're going to do is we're going to use the same common external tangent procedure that we've used in prior chapters, and I'm going to draw a line that's parallel now to, let's call this CD, from B, the smaller circle, to the radius of the larger circle. And what I've just done is I've created a rectangle because we know that these are right angles, and I said that we'll call this point E. EB is going to be parallel to CD. So in this case I know that EC is now 15 minus 3, or 12. And I know what's left, I'm sorry, this is 3. EC is 3, and E to A is 12. I also know the distance between A and B, which is given, is 24. Now, oddly enough, this is looking like one of my special families of right triangles. It's going to be, I've got one angle or one side that's half the length of the hypotenuse. So we know AB is the hypotenuse, and EB is one of the legs, and EA is the other leg. So I have a 12-24 triangle. I should notice that it's going to be a 30-60-90 triangle, where this angle here is 30 degrees. This is ABE, and angle BAE is going to be 60 degrees. And so I know that EB, the length of EB, is going to be 12 root 3, and I know that CD is 12 root 3. And we'll call this point F and G. If we run a similar external tangent process through A, B, G, and F, we'll find that FG is also 12 root 3. So now all we're left with is finding the distance from C, the arc length, from C to F, and then from D to G. Well, we know the angle measures here. This is 60 degrees. And if we had done the process of running or figuring out the external tangent length from F to G, we would have noticed that FAB angle is also going to be 60 degrees. So this entire length here is 120 degrees, which leaves us with 240 degrees covering the arc length of CF. So we can figure out what that length is. On this side, we know that this angle measure is 30 degrees, and we know a similar measure is going to be 30 degrees. And we have two right triangles, so the measure from D to B is 90, plus the angle measure of EBA, which is 30, and AB, we'll call this I, is 30, plus IBG is 90. So we have 90 plus 30 plus 90 plus 30, which gives us 180 plus 60, or 240 degrees for this measure here. That leaves us with 120 degrees for the arc length DG. So now what we have to do is figure out that portion of the circumference that relates to this distance, and so we'll tackle the larger circle first. In the larger circle, we know that the arc length, or the central angle measure, is 240 degrees out of 360 degrees, where that equals 2/3. And we also know that the circumference is 2 pi r, so we'll multiply this by 2 pi times the radius of 15, and we will end up with 60 pi over 3, or 20 pi. So this is the length from C to point F, and this smaller circle, the length, the portion of the circumference that we're cutting out from D to G, is going to be now 120 over 360, or 1/3 of 2 times pi times the radius of 3, which is going to be equal to 2 pi. So now all I have to do is add my values together. 2 pi plus 20 pi is 22 pi, and then I have 12 root 3 plus 12 root 3 is 24 root 3. So my answer ends up as 24 root 3 plus 22 pi. In this case, it's going to be centimeters, but we've just been dealing with units. And there's your answer.